Hi, today we're collecting data for the molar mass by freezing point depression. It's nice to see you. First off, we need to measure the mass of 3 milliliters of our unknown. And so the first thing we're going to do is this little thing here is a weighing bottle. And it's nice because it's got this tight ground glass joint so that it'll seal good. So we're going to go measure the mass of this empty. So that's what I'm about to do. The balance is tared, and I can measure the mass of my weighing bottle. There's the weighing bottle on the balance, and when this little dot disappears, it's equilibrated. So there's our measurement of the mass of the bottle empty. Now I'm measuring out 3 milliliters of the unknown into the tared weighing bottle. So I'm just going to take the top off that. And here is a little beaker with the unknown. It's unknown number 8. And I don't know if you can see, but let me see if I can see. There's this little line there right behind my finger, or in front of my finger, that shows how to fill this up. And this is a 3 milliliter volumetric pipette. So it'll measure 3 milliliters when I fill it up so that the bottom of the meniscus is just going to touch that little line. So to do this, you take a bulb, depress it, put it in there, fill up the pipette above that little line, and then I'm going to put my finger over the top. And now I have to lift up my finger and let the liquid go down until it hits the line. There, that's good. There we are. And now I'll let it drain into the weighing bottle. And we just let it drain until you don't see a drop for about 5 seconds. Still dripping. There, 1, 2, 3, 4, 5. There's a little extra, so I'm going to touch that off, get rid of the drop that's on the outside. Here's the tared balance, and so now I'm going to put in the weighing bottle with the 3 milliliters of unknown. So there it is, and I just have to wait for a second. And there's our measurement. So this is the freezing point apparatus, and it's just a large test tube with this metal sort of spring-like thing in the middle. And the point of this is that the thermometer is going to flit down through the middle of the little spring, and then when this is in there, we can sort of take this and we can agitate up and down to mix the solution and make sure the temperature is uniform inside the test tube. So the outside, we're going to make a salt and ice bath around it, and we're going to put this down in here, sort of like this. Around will be salt and ice. That'll be cold, so relatively cold, like -5, -7 degrees Celsius. And we just want to make sure that the inside cools down sort of uniformly, that the outside doesn't get colder before the inside gets colder. So first off, we're going to make our first sample. It's going to be 25 milliliters of water and 3 milliliters of the unknown. I measured the temperature of the I measured the temperature of the water, and I'm going to, it's 18.6 degrees Celsius. And now I'm going to measure up 25 milliliters of water and 3 milliliters of unknown. And I'm going to use, I got a bigger 25 milliliter volumetric pipette, and I'm going to use the same 3 milliliter volumetric pipette to measure out the unknown. So let me do that. I did want to show you how to make a good salt ice bath. So in here I have a beaker, and I filled it up with about this far with ice, and then I covered that layer of ice with just a sort of enough salt that it completely covers the top. Did it 2 more times. So the big thing is you need to mix together the salt and the ice really well to get the lower temperature. So once you put the salt and ice together, you gotta agitate them to sort of get everything cold. So I'm just using a glass stir rod to move this stuff around. And you can see that there's been the salt or the ice has sort of shrunk a little bit, so I'm going to add a little bit more ice and another bit of salt. So I'm filled up again with salt and ice. I'm just gonna and so you just get it well mixed and let it get cold. I don't know if you can see it, but we're starting to get some frost on the outside. I have a digital thermometer that's nice and easy for measuring this. And right now at the bottom, I'm measuring -9 degrees about. So it did get cold, but it's important to get it kind of slushy. The water at the bottom, that helps conduct heat away from the sample very well. So you don't want it just ice. You want it sort of this combination of ice and salt and water, and it'll get really cold. So I'm putting the freezing point apparatus together. This little thing is called a split top stopper. It's got a hole in the middle, but then it's got this cutout. And so I can take the thermometer and just sort of lay it in that little cutout. And then I'm going to put this in here so that the thermometer goes down the center of the little spring stirrer. Oops, I gotta move it down a little bit farther. Let me show you here. So the stirrer is sitting inside that little cutout, and so I can move it up and down. And you can see that the bottom of the thermometer is a little bit above the bottom of the test tube. So now I'm gonna take this and just lower it down so that it will sort of firmly get down to the bottom of the I have to tighten this a little bit. Adjust it. All right, so that's doing pretty good. Now I'm gonna move this up and down and measure the temperature every 30 seconds. And you'll get that data separately. So I'm gonna start a timer here. And our first measurement is, let's see, it is at 19.0. So I'll just continue on doing these measurements for about 10 minutes. So this is the first trial with the unknown solution mixed with water. Oops, I'll turn this off. And I went for about 8 minutes. And I followed the temperature until I got 5 measurements in a row at the same temperature. And at phase transitions, the temperature tends to stay constant. So that's a good indication, that plateau that we measured the freezing point. I don't know if you can see, but there's actual kind of frost on the outside of the thing. So if we measure the temperature of the bath, I just want to make sure that it is cold enough. So we want to make sure we measure something below the temperature that we got. And you can see, yeah, this is a real good bath. It's about minus 12 degrees, right around there, maybe a little bit lower. And if we look at the sample, yeah, we can see that it has, whoops, there we go, it's frozen on the inside. And I'm going to make another measurement just like the first. I'm going to use the same sample. I'm just going to warm it up with my hand until it melts, and then I'm going to sort of refresh the ice bath, and then I'll be able to make another set of measurements so I get some reproducibility. All right. I did a second trial of the freezing point of the mixture of water and the unknown, and then I emptied out the freezing point test tube, rinsed it out completely, dried it out. It's important to make sure that there's no contaminants for the second part of the experiment, or I should say the second set of freezing point measurements. In this second set, we're going to just have pure water in here. I'm going to measure out 25 milliliters with a volumetric flask, and then use the salt and ice bath to measure the freezing point of water, just pure water. And we know that should be 0.0 degrees Celsius. What we're doing in the second part is calibrating the thermometer. So the thermometer may not read freezing point as 0.0 degrees Celsius. And in that case, we need to adjust the measurements we made earlier. So like if I measure the freezing point with this thermometer as minus 0.5 degrees Celsius, I know that the thermometer is reading 0.5 degrees too low, and so I should adjust up the freezing point of the mixture by 0.5 degrees. So this is a calibration to check our thermometer. I've finished the second measurement of the freezing point of pure water. I did want to show you, I was checking the temperature afterwards, and you can see you can get really cold mixtures of salt and ice. Yeah, minus 15. A little bit earlier it was reading minus 16. It's around minus 15 right now. So these are salt ice baths can be very effective. One of the keys is this time, just before I did the trial, I poured off as much of the water as possible and added more salt and ice. Remember, when you pour off water, you're carrying away some of the salt, and so not only do you need to add more ice, you also need to add more salt to replace that was gone. And then the other key is mixing it up really good. Let me pause this for a second. I'll show you the container when it comes out. So here's the container, here's the freezing point apparatus after this is a few minutes after the end of the trial. So during the trial, the pure water was in the process of freezing, and now I don't know if you can see. Oh yeah, I can't move it. I can't move this at all because it's frozen in there. So this is, I have to warm it up a little bit if I wanted to get it to move. So let me see if I can show you that. Sometimes, not so much this time, but sometimes when you pull these freezing point apparatuses out with the water, you'll just see it'll look like it's just liquid water because it's entirely clear. You don't see any air bubbles trapped by the ice, but it will be frozen, and when you start to move it, you'll see that. But let's see if I can get it. No, couldn't get it. You can see the top is a little bit liquid up there, but it's still solid. Anyway, that's the end of the data collection for molar mass by freezing point depression.